Hey calculus friends, this is the last video you're going to be getting from me. This is our unit 10, which is our volume, where we talked about the disk and the washer method to find the volume. This is our test review. There's 2 problems, but the first problem has 4 parts and the second one has 3 parts. I'm going to do my best on the time, but I want to make sure that I walk through each one of these because this is very similar to what you're going to see on the test that I'm giving you. So please make sure you follow along. If you've got questions, please make sure you reach out to me so I can answer those questions. Okay. As we go through, I'm going to talk about how we know if it's a disk method, how we know if it's a washer method, when we need to change our equations to be in terms of y, and all that stuff. So please, please, please take your time and watch this whole video. Okay, number 1, we have y equals x squared, y equals 0, and x equals 2. So that's our region that we are forming, and we want to know when it's rotated about these 4 different places. So when it's rotated about the x-axis, y-axis, then the line y equals 4, and then the line x equals 2. Okay, so let's start with the first one. It says when we revolve this around the x-axis. So that means we're going to take this. So these ones are nice. They're already graphed here for us. So we're just really worried about what we're doing. So this is the shaded region that we're going to find the volume of when we revolve it around the x-axis. So that means we're going to revolve it around this line. So those of you who are my visual people, that means we're going to have something that looks like this-ish. Not very good at drawing it upside down, but it's going to be a completely solid, kind of like a cone or a funnel turned sideways. Okay, so first thing that I want to note is that we're revolving it around the x-axis. So this is a horizontal rotation, which means we're going to use x values everywhere. So that means our equations are already in terms of x, so we don't have to do anything to our equations. Okay. The second thing I want to note is this a washer method or is this a disk method? So the way we know is this is a completely solid object. Okay. There is no openings, no spaces, no gaps anywhere when I revolve this. So because there is no spaces, so because there's no space, that's how I know we are going to be using the disk method. So just for a reminder, for those of you who need it, the disk method says that the volume is going to be equal to pi times the integral from a to b, so our lowest value of our region to the highest value of our region. Then we're going to take the outer radius and square it. Sorry, the outer radius minus the inner radius and square it with respect to x. Okay. We'll come back and write the washer one when we need it. Okay, so that means that we need to find the radius to the outer function and the radius to the inner function. So because we're revolving it around the axis in which it's touching, I don't really have a radius to the inside because it's going to go from here to here. So when I talk about this, the radius to the outside is to the function itself. So our big R of x is really going to be the distance to that function, which here is x squared. And then our inner radius is really from the x-axis to the x-axis, which is a distance of 0. So when we plug this in, this is really going to be a 0 here. So sometimes you might not even put it, but I'm going to put it just so we're all very clear on what we're doing here. So this is going to be volume is equal to pi. Now remember, our lower and upper integral, so where we're taking our integrand, is because these are x's, I need the smallest x that we have to the biggest x we have. So this is a 0 and this is a 2. So this is 0 to 2. Okay, then I'm just going to plug in the outer radius and the inner radius. This is going to be x squared minus 0, all of it's going to be squared with respect to x. Okay, when you type this in to the calculator, okay, I'm not going to show you guys that. If you need me to do that for you, I can do that separately, but we've been doing this for a while now. So this is going to give us the volume as approximately. The reason I've changed from equals to approximately is because now I'm going to give a decimal answer. If you leave your answer in terms of pi, you can leave this an equal sign. But if you're going to multiply it by the pi and write it as a decimal, it needs to say it's approximately, because you're not giving an exact answer. You're giving a rounded answer now. So it's going to be 20.016. And again, I'm rounding to 3 decimals on all the things that I'm doing. Okay? Now, part B. Using the exact same equations, this exact same region. So here's our region. Except this time, we're going to revolve it around about the y-axis. So that is here, the y-axis. Okay, so remember, if we're revolving around the y-axis, this is a vertical rotation. Okay, so my people who like a visual, this one is going to look like this. Okay, so this one's going to kind of look like maybe a can of soup or something on the outside, because it's going to be a solid cylinder, but the inside looks like someone scooped out the middle. So maybe like a cup or a bowl that has, you know, the cylinder, the full cylinder on the outside. So because we're doing this vertical rotation, that means we're going to be using y's. And because we have space on the inside and it's not a complete solid, so this is all the space, that means we're going to be using the washer method. Okay, because we have that space. Okay, sometimes that space goes completely through and you have a complete hole. Sometimes it's just an open space. So make sure that you're okay with the difference here between what we're looking at. Okay, so when I say in terms of y, that means these equations need to be x equals, and then this part needs to be y's. So that means we need to change our equations. So change equations. Alright, so that's the first thing I'm going to do. I'm going to change my equations. So that means I'm going to take y equals x squared, and I want to solve it for x. So to get rid of our square, we're going to square root both sides. So I have x equals the square root of y. Now I'm not going to do the plus and minus here, because here the y's that we're looking at are all the positive y's. I don't have any of the negative y's. Okay, so this is my first equation. Okay, that represents this line, or sorry, not line, this quadratic right here. Then my other equation, okay, I already have an equation over here that's solved for x, so that's probably the one that I'm going to need. So I'm going to go ahead and write it here just so we see it. So these are the two equations that are in terms of y. Okay, so now we have to remember, well, what's our washer method? Like, what is that equation? It's very similar to the disk, except just a little bit different. So the volume is equal to pi. This time, we're still doing our the integral of our lower to our upper limit. Okay, on this one, we're going to have y values, so it doesn't really matter that I use a or b, or you could use a c or d. It doesn't really matter. But the washer method means that we're doing this because this is the area of one piece, but then we have to subtract it out again. So this means we're going to be doing really the outer radius part squared. Then we're subtracting the inner radius part squared. So these are going to be done separately and being subtracted, because what we're doing is we're finding the area of one, and then we're subtracting out the empty piece on the inside. So that's why we have to do the subtracting part. Alright, so that means we need to find our radius to the outer. Okay. On this one, I'm going to use r of y because things are in terms of y. So our radius to the outer, so we're going from where we rotate to the outer function of our shaded region. So this whole distance is the distance that I need. Well, this one's really easy. We can really just count this. So the capital R of y, so this is our outer radius, is just going to be a distance of 2. Okay, if you want to do 2 minus 0, so you're seeing that subtraction here, that's a distance of 2. The inside of that is 0, so 2 minus 0. Our inner radius is going to be from our y-axis to this function. Okay, so that just means if I know this distance, which we do, it's our equation, then we can just write that in. Okay, so this is going to be the square root of y, and if we subtract out this piece, then it's minus 0, which is just still the square root of y. Okay, so our volume, we're going to fill it in, is pi times, this time, remember our lower and upper limit needs to be in terms of y. So that means the lowest y to the highest y. So this is a 0 to a 4. Then we have 2 squared minus the square root of y squared dy. Okay, when we punch that into our calculator, we're going to get that our volume is approximately 25.133. Okay, so hopefully you're seeing the difference in those two problems so far. Now we're going to take them and we're going to revolve them a little bit differently. Okay, so C says revolve it around the line y equals 4. So that means we need to find y equals 4. Okay, so that means the y value of 4. So 1, 2, 3, 4. That's going to be up here. It should go right through that point. So this is where we're going to revolve it around. Okay, this is a horizontal rotation, so that means we're going to be using x's. So we do not have to change any equations. Okay, this is still the section, the region that we're going to revolve. So if we drew a picture of it, this one would go up here like this. Okay, it's going to look very similar to the one we just did, except sideways. Okay. Alright, so now what we're going to do is let's figure out, is this washer or is this disc? So we're going to notice that we have this bunch of empty space here. So if we have space, that means we're going to be using a washer method. The washer method. Sorry, that R is really not very good. The washer method. Okay, so let's find the radius to the outside. So from the line that we are revolving around to the outside, so that's here. So this one's pretty easy. That's just that whole distance, which is a 4. You want to do 4 minus 0, so you remember the next piece that you're finding that distance to is that 0. Okay. Then our inner radius, okay, is going to be from here to this function. Now, this one's a little bit more, a little bit different because we have this is what we need. So little r of x. We know this whole distance is 4. And we can subtract out this piece down here, which we know is this function. So we're going to subtract out that function, x squared. So 4 minus x squared. That'll give us this piece that's left. So the whole thing is 4. If I take this piece away that we know, because that distance will always be the function, then I'll be left with that piece. Okay, so that means we have the volume equals pi. Okay, this one's 0 to 2 because we're using x's. So then we have 4 squared minus 4 minus x squared squared dx. And when we plug that in, we are going to get approximately 46.914. Okay, I'm going to pause here because my time is running out, and I will pick up with D and the rest of this on my next video.